Hello students, welcome to Don Bosco PU College online classes. We are trying our best to make teaching learning experience easy to our students. So subscribe to our YouTube channel and press the bell icon to never miss any update. Hello students, welcome to the physics classes. This is Razika. In the last video we had discussed about 1, 2 and 3 marks questions of the March 2020 physics question paper. In this video we'll be solving 5 marks questions. So in this main you have to answer any 3 questions kotirtara. You have to answer just any 2 of the following given questions. Alright. So idralli 27th question is derive the expression for conductivity of material, that is kodbittidare our equation na sigma is equal to ne square tau by m, where the terms have their usual meaning. ಸೊ ಕಂಡಕ್ಟಿವಿಟಿಗೆ ಎಕ್ಸ್ಪ್ರೆಷನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಸೊ ಒಂದು ಕಂಡಕ್ಟರ್ನ ನಾವು ಒಂದು ಬ್ಯಾಟ್ರಿಗೆ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ದೀವಿ. ಆಸ್ ಎ ರಿಸಲ್ಟ್ ಫೀಲ್ಡ್ ಡೈರೆಕ್ಷನ್ ಈ ಥರ ಇದೆ ಆ್ಯಂಡ್ ಕರೆಂಟ್ ಡೈರೆಕ್ಷನ್ ಈ ಥರ ಇದೆ. ಓಕೆ, ಆ್ಯಂಡ್ ದ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫ್ರೆನ್ಸ್ ಅಕ್ರಾಸ್ ದ ಬ್ಯಾಟ್ರಿ ಈಸ್ ವಿ. ಸೊ ಕನ್ಸಿಡರೇಷನ್ ಬರೀಲೇಬೇಕು. ಕನ್ಸಿಡರೇಷನ್ಸ್ ಆರ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಕನ್ಸಿಡರ್ ಅ ಮೆಟಾಲಿಕ್ conductor of length L and uniform cross section area of cross section A. Okay, A is the cross sectional area. So let n be the number of free electrons per unit volume in the material. Okay, so idu ondu consideration ಬರ್ದಿದ್ದೀವಿ. Consider a metallic conductor whose length is L and uniform cross sectional area A. Let n be the number of free electrons per unit volume. So when the potential difference is V, okay, and it is applied across the ends. So applied across the ends of the conductor. Okay, applied across ends of the conductor the electric field, EF andre electric field, ನೀವು full forms ಬರಿಬೇಕು exam ಅಲ್ಲಿ. The electric field produced inside the conductor is okay, E is equal to V by L. So ಒಂದು ಕಂಡಕ್ಟರ್ ಇದೆ whose length is L, ಅದರ across the ends of the conductor V ಅಷ್ಟು potential difference ನ if you supply, E will be equal to V by L. I'll call this as equation 1. So we are beginning this equation from E is equal to V by L. ಇದರಿಂದ V is equal to E into L ಆಗುತ್ತೆ. Next, using expression for drift velocity ನಮಗೆ ಆಲ್ರೆಡಿ ಗೊತ್ತಿದೆ ಇದು. ಸೊ ಇದನ್ನು ನಾವು ಡೈರೆಕ್ಟ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಯೂಸಿಂಗ್ ದ್ಯಾಟ್ ಈಕ್ವೇಷನ್ VD is equal to E tau divided by M. ಇದನ್ನು ನೆನ್ಪಿಟ್ಕೋಬೇಕು ನೀವು. ಡ್ರಿಫ್ಟ್ ವೆಲಾಸಿಟಿ is VD is equal to E tau by M. ಸೊ ಇದು ಸೆಕೆಂಡ್ ಈಕ್ವೇಷನ್. This is third equation. Alright. So ಈ ವ್ಯಾಲ್ಯೂನ ಈ ಈಕ್ವೇಷನ್ ಅಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು. ವಿ ಹ್ಯಾವ್ ಟು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಇ ಇನ್ ದಿಸ್ ಈಕ್ವೇಷನ್. ಸೊ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದರೆ ಏನು ಮಾಡ್ತಿದ್ದೀವಿ ನಾವು? ಸಬ್ಸ್ಟಿಟ್ಯೂಟಿಂಗ್ ಇ ಇನ್ ಈಕ್ವೇಷನ್ 3. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ? ವಿ ಡಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಇ ಟೌ ಡಿವೈಡೆಡ್ ಬೈ ಎಮ್ ಇಂಟು ಈ ಪ್ಲೇಸಲ್ಲಿ ವಿ ಬೈ ಎಲ್ ಅಂತ ಬರೀತೀನಿ. ಓಕೆ, ವಿ ಬೈ ಎಲ್. ಸೊ using the relationship between drift velocity and current, using the relationship between VD and I, drift velocity ಮತ್ತು current relationship ನ ಯೂಸ್ ಮಾಡಿದ್ರೆ what will happen? I is equal to NEAVD ಬರುತ್ತೆ. I is equal to NEAVD. ಸೊ ಈ ವಿ ಡಿ ಪ್ಲೇಸಲ್ಲಿ ವಿ ಡಿ ವ್ಯಾಲ್ಯೂನ ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ತೊಗೊಂಡು ಬಂದು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ. ಐ ಇಸ್ ಈಕ್ವಲ್ ಟು ಏನಾಗುತ್ತೆ? NEA ಇ ಟೌ ವಿ ಡಿವೈಡೆಡ್ ಬೈ ಎಮ್ ಇಂಟು ಎಲ್ ಆಯಿತು. ಆಲ್ ರೈಟ್. ಸೊ ದಿಸ್ ವಿಲ್ ಬಿ, ಇದನ್ನು ರಿಅರೇಂಜ್ ಮಾಡ್ತೀನಿ ನಾನು. ಫ್ರಮ್ ಓಮ್ಸ್ ಲಾ ವಿ ಬೈ ಐ, ಸೊ ಇದನ್ನು ಈ ಕಡೆ ತಗೋತೀನಿ. ವಿ ಬೈ ಐಗೆ ರಿಅರೇಂಜ್ ಮಾಡಬೇಕು. ಸೊ ವಿ ಬೈ ಐಗೆ ರಿಅರೇಂಜ್ ಮಾಡಿದರೆ ಐ ಈ ಕಡೆ ಬಂದರೆ ಎಮ್ ಇಂಟು ಎಲ್ ನ್ಯೂಮರೇಟರಿಗೆ ಹೋಗುತ್ತೆ, ಡಿವೈಡೆಡ್ ಬೈ ಎನ್ ಇ ಸ್ಕ್ವಯರ್ ಎ ಟೌ ಆಯಿತು. ಓಕೆ, ಸೊ ವಿ ಬೈ ಐ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎಮ್ ಎಲ್ ಡಿವೈಡೆಡ್ ಬೈ ಎನ್ ಇ ಸ್ಕ್ವಯರ್ ಎ ಇಂಟು ಟೌ ಆಯಿತು. ಸೊ ಫ್ರಮ್ ಓಮ್ಸ್ ಲಾ ನಮಗೇನು ಗೊತ್ತು ಅಂತ ಹೇಳಿದರೆ ವಿ ಬೈ ಐ ಇಸ್ ಈಕ್ವಲ್ ಟು ಆರ್. ಸೊ ಇದನ್ನು ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೋಣ. ಆರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎಮ್ ಎಲ್ ಡಿವೈಡೆಡ್ ಬೈ ಎನ್ ಇ ಸ್ಕ್ವೇರ್ ಎ ಟೌ ಆಯಿತು. ಓಕೆ, ಸೊ ನೆಕ್ಸ್ಟು ನಮಗಿನ್ನೂ ಬೇಕಿರೋದು ಕಂಡಕ್ಟಿವಿಟಿ ಬೇಕಿರೋದು, ವಿಚ್ ವಿ ಹ್ಯಾವ್ ನಾಟ್ ಗಾಟ್ ಇಟ್. ನಾವು ರಿಲೇಷನ್ಶಿಪ್ ಬಿಟ್ವೀನ್ ಆರ್ ಆ್ಯಂಡ್ ರೋ ಬರೀತೀನಿ ನಾನು. ಓಕೆ, ಸೊ ಆರ್ ಆ್ಯಂಡ್ ರೋಗ್ ರಿಲೇಷನ್ಶಿಪ್ ಆರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ರೋ ಎಲ್ ಬೈ ಎ ಇದೆ. ರೆಸಿಪ್ರೋಕಲ್ ಆಫ್ ಇದು ರೆಸಿಸ್ಟಿವಿಟಿ, ಇದು ರೋ ಅಂದರೆ ರೆಸಿಪ್ರೋಕಲ್ ಆಫ್ ರೆಸಿಸ್ಟಿವಿಟಿ ಇಟ್ಸ್ ಕಂಡಕ್ಟಿವಿಟಿ. ಸೊ ಇದನ್ನು ನಾನು ರಿಅರೇಂಜ್ ಮಾಡ್ಕೋತೀನಿ. ಬಿಫೋರ್ ರಿಅರೇಂಜಿಂಗ್ ಆರ್ ವ್ಯಾಲ್ಯೂನ ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿಬಿಡ್ತೀನಿ. ಎಮ್ ಎಲ್ ಡಿವೈಡೆಡ್ ಬೈ ಎನ್ ಇ ಸ್ಕ್ವೇರ್ ಎ ಟೌ ಇಸ್ ಈಕ್ವಲ್ ಟು ರೋ ಎಲ್ ಡಿವೈಡೆಡ್ ಬೈ ಎ. ಸೊ ಎಲ್ ಆ್ಯಂಡ್ ಎಲ್ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ, ಎ ಆ್ಯಂಡ್ ಎ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಉಳಿದಿರೋದೇನಿಲ್ಲಿ ಎಮ್ ಡಿವೈಡೆಡ್ ಬೈ ಎನ್ ಇ ಸ್ಕ್ವಯರ್ ಟೌ ಇಸ್ ಈಕ್ವಲ್ ಟು ರೋ. ಸೊ 1 ಬೈ ರೋ ಏನಾಗುತ್ತೆ? ಇದನ್ನ ಈ ಕಡೆ ತೊಗೊಂಡ್ರೆ 1 ಬೈ ರೋ ವಿಲ್ ಬಿ ಈಕ್ವಲ್ ಟು ಎನ್ ಇ ಸ್ಕ್ವಯರ್ ಟೌ ಬೈ ಎಮ್. ಸೊ ಹಿಯರ್ 1 ಬೈ ರೋ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಸಿಗ್ಮಾ, ವಿಚ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎನ್ ಇ ಸ್ಕ್ವಯರ್ ಟೌ ಬೈ ಎಮ್. Reciprocal of resistivity is conductivity. So we have obtained the expression for conductivity, which is Ne square tau by m. Once again I'll explain. First idana ee expression na baribeku. Electric field is given by V by L. ಆಮೇಲೆ ಡ್ರಿಫ್ಟ್ ವೆಲಾಸಿಟಿಗೆ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಇ ಟೌ ಬೈ ಎಮ್. ಇದರಲ್ಲಿ ಈ ವ್ಯಾಲ್ಯೂನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ. Then you have to write the relationship between VD and current. So this is the expression, and in this value substitute the value of VD and arrange it to get V by I is equal to ML divided by Ne square A tau. Next, in place of V by I you can substitute R from Ohm's law. So if V by I place alli R na substitute ಮಾಡಿದ್ರೆ R is equal to ML divided by Ne square A ಟೌ ಆಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ದ ರಿಲೇಷನ್ಶಿಪ್ ಬಿಟ್ವೀನ್ ಆರ್ ಆ್ಯಂಡ್ ರೋನ ಯೂಸ್ ಮಾಡಬೇಕು, ಬಿಕಾಸ್ ವಿ ನೀಡ್ ಟು ಫೈಂಡ್ ಔಟ್ ದ ಕಂಡಕ್ಟಿವಿಟಿ ವ್ಯಾಲ್ಯೂ. ಸೊ ಆರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ರೋ ಎಲ್ ಬೈ ಎ. ಆರ್ ವ್ಯಾಲ್ಯೂ ವಿ ಆಲ್ರೆಡಿ ಹ್ಯಾವ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟೆಡ್. ಎಲ್ ಎಲ್ ಆ್ಯಂಡ್ ಎ ವಿಲ್ ಗೆಟ್ ಕ್ಯಾನ್ಸಲ್ಡ್ ವಿತ್ ಈಚ್ ಅದರ್. ಸೊ ಯು ವಿಲ್ ಹ್ಯಾವ್ ಎಮ್ ಡಿವೈಡೆಡ್ ಬೈ ಎನ್ ಇ ಸ್ಕ್ವೇರ್ ಟೌ ಇಸ್ ಈಕ್ವಲ್ ಟು ರೋ. Take this row this side, send the other terms another side. So 1 by rho is equal to Ne square tau by m. If you take the reciprocal, 1 by rho is equal to sigma. So Ne square tau by m. Let's move on to the next question. 28th question. obtain the expression for the force between two straight long parallel conductors carrying current. Hence define ampere. So definition of ampere kuda bariri anta helidare. So first I have mentioned the definition of ampere here. Electric current through a conductor is said to be 1 ampere if 1 coulomb charge flows through any cross section of conductor in 1 second. So there are many definitions for 1 ampere. We have used one simplest definition, that is electric current through a conductor is said to be 1 ampere if 1 coulomb charge flows through any cross section of conductor in 1 second. So two straight long parallel conductors madhya iro force na you have to calculate here. Okay, so here there are two conductors, conductor A and conductor B. Both the conductors have same length. The distance of separation between the conductors is small d. So let IA be the current flowing through the conductor A and IB be the current flowing through the conductor B. So this FAB is the force experienced by the conductor B towards A, and BA is the magnetic field experienced by the conductor B. So this FBA and BA are mutually perpendicular to each other. Alright, so let's write, consider two long parallel straight conductors. Their names are A and B, separated by a distance A, sorry, D, separated by a distance D, carrying currents IA and IB respectively, IA and IB. So first let us write the force. Let the force experienced by conductor of length LB. Okay, let the force experienced by a conductor B of length L, some small element of length consider ಮಾಡಿದೀವಿ. So Lorentz force in the FBA is equal to ILB ಅಂತ ಬರೀತೀವಿ ನಾವು. ಓಕೆ, ಇಲ್ಲಿ ಲೆಂತ್ ಕನ್ಸಿಡರ್ ಮಾಡಿರೋದು ಕ್ಯಾಪಿಟಲ್ ಎಲ್ ಬಿ. ಇಲ್ಲಿ ನೋಡಿ, ಇದರಲ್ಲಿ ರನ್ ಆಗ್ತಾ ಇರೋ ಕರೆಂಟು ಐ ಬಿ. ಸೊ ಇಲ್ಲಿ ಐ ಬಿ ಅಂತ ಬರೀಬೇಕು. ಲೆಂತ್ ಇಸ್ ಎಲ್ ಓನ್ಲಿ. ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇಸ್ ಬಿ ಎ. ಇಲ್ಲಿ ತುಂಬ ಜನ ಮಿಸ್ಟೇಕ್ಸ್ ಮಾಡ್ತಾರೆ. ಐ ಎ ಎಲ್ ಬಿ ಎ ಆರ್ ಬಿ ಬಿ ಬರೀತಾರೆ. ಎಫ್ ಬಿ ಎ ಅಂತ ಇದ್ರೆ ಯು ಹ್ಯಾವ್ ಟು ರೈಟ್ ಐ ಬಿ ಎಲ್ ಬಿ ಎ ಸೈನ್ 90 ಡಿಗ್ರಿ, ಸೈನ್ ತೀಟಾ ಆ್ಯಕ್ಚುಲಿ ಸೈನ್ 90 ಆಗುತ್ತೆ, ಸಿನ್ಸ್ ದಿಸ್ ಆ್ಯಂಡ್ ದಿಸ್ ಆರ್ ಮ್ಯೂಚುಯಲಿ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಟು ಈಚ್ ಅದರ್. ಸೊ ಯುಲ್ ಹ್ಯಾವ್ ಎಫ್ ಬಿ ಎ ಇಸ್ ಈಕ್ವಲ್ ಟು ಐ ಬಿ ಎಲ್ ಬಿ ಎ, ಸೈನ್ 90 is 1. So this is equation 1. Next, from Ampere's circuital law, Ampere's circuital law, the magnetic field is given by, okay, from Ampere's circuital law, idral BA bekalla namige, that is why. So BA is equal to mu naught I divided by 2 pi r ಅಂತ ಇತ್ತು, ಇಲ್ಲಿ d ಅಂತ ಬರಿತೀವಿ, the distance. ಸೊ I here is a ಅಂತ ಬರಿಬೇಕು. ಈ ಬಿ ಎ ಬರ್ತಾ ಇರೋದಿಲ್ಲಿ ಡ್ಯೂ ಟು ದಿಸ್ ಕರೆಂಟ್ ಐ ಎ. ಸೊ ಬಿ ಎ ಇಸ್ ಮ್ಯೂ ನಾಟ್ ಐ ಎ ಡಿವೈಡೆಡ್ ಬೈ 2 pi d. ದಿಸ್ ಇಸ್ ಈಕ್ವೇಶನ್ ನಂಬರ್ 2. ಸೊ ಇದನ್ನು ಇದರಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಎಫ್ ಬಿ ಎ ಇಸ್ ಈಕ್ವಲ್ ಟು ಐ ಬಿ ಎಲ್, ಓಕೆ, ಬಿ ಎ ಪ್ಲೇಸಲ್ಲಿ ಮ್ಯೂ ನಾಟ್ ಐ ಎ ಡಿವೈಡೆಡ್ ಬೈ 2 pi d ಆಗುತ್ತೆ. ಸೊ ದಿಸ್ ವಿಲ್ ಬಿ mu naught ಡಿವೈಡೆಡ್ ಬೈ 4 pi ಅಂದರೆ 2 ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಆ್ಯಂಡ್ ಡಿವಿಷನ್ ಮಾಡಿದರೆ ಲೈಕ್ ದಿಸ್ 2 and 2 ಮ್ಯೂ ನಾಟ್ ಡಿವೈಡೆಡ್ ಬೈ 4 pi ಹೊರಗಡೆ ಬರುತ್ತೆ ಆ್ಯಂಡ್ ಒಳಗಡೆ 2 IA IB divided by D. Okay, so mu naught divided by 4 pi 2 IA IB ಇನ್ನೊಂದು L ಕೂಡ ಇದೆ ಇಲ್ಲಿ. ಓಕೆ, ಸೊ ಇಲ್ಲಿ L ಇದೆಯಲ್ಲ, ಆ L ಇಲ್ಲಿ ಬರುತ್ತೆ. ಸಿಮಿಲರ್ಲಿ ಆಲ್ರೈಟ್ FBA we have written. Similarly FAB is equal to IA. See, already you have written here the equations. Reverse these equations and write. For FBA, if it is IBLBA, you have to write FAB is equal to IBLBB. Okay. Similarly, BB is equal to mu naught IB divided by 2 pi D. This is equation 3, and this is 4, this is 5. Substitute 5 in B. ಇದನ್ನ 4 ಅಲ್ಲಿ substitute ಮಾಡಿ. So FAB is equal to IBL mu naught IB divided by 2 pi D. So again ಇದನ್ನು ಕೂಡ 2 by 2 ಇಂದ division and multiplication ಮಾಡಿಕೊಂಡ್ರೆ ನಮಗೇನು ಸಿಗುತ್ತೆ? FAB is equal to mu naught divided by 4 pi 2 IA IB L divided by 2 you will have. Okay, now from equations 3 and 4, from 3 and 6. Okay, ಇಲ್ಲೂ ನೋಡಿ FBA is equal to mu naught by 4 pi 2 IA IB L by D ಬಂದಿದೆ. ಇಲ್ಲೂ 2 IA IB L divided by 2 D ಬಂದಿದೆ, not 2 D ಬಂದಿದೆ. Okay, so both are same. We can write FAB is equal to FBA. Suppose if you are writing in vector form, you will have FBA is equal to minus of FAB. Okay, FBA is equal to minus of FAB ಬರುತ್ತೆ. So this is the derivation. ತುಂಬಾ simple ಇದೆ. Only these 2 steps, these 3 steps if you remember, the rest of the derivation is very easy. So major force now we are writing using Lorentz force ILB sin theta. Here the subscripts which you are writing, you have to be careful when you write IBLBA. Okay, when you are writing FBA. So again from Ampere circuital law, find out what is BA. So BA is equal to mu naught IA divided by 2 pi D. Substitute this BA value here and you will get divide and multiply by 2. You will get FBA as equal to mu naught by 4 pi 2 IA IB L divided by D. In the next case, that is when you are going to write FAB values, all the steps are similar, but the subscripts will be reversed. Here you have FBA, here you will have FAB. Here you have IB, here you have IA. Here you have L is same. Here you have BA, here you will have BB. Okay, similarly the last step idu kuda IA idu fine. The last step will be same. This and this are same. So vectorically if you write FBA is equal to minus of FAB. Next, moving on to the 29th question. With the help of labeled diagram, derive the expression for instantaneous EMF induced in an AC generator. ಸೊ ಇಲ್ಲಿ ಒಂದು AC ಜನರೇಟರ್ದು ಲೇಬಲ್ಡ್ ಫಿಗರ್ನ ಬರ್ದಿದ್ದೀವಿ ನಾವು. ಇದರಲ್ಲಿ ಬರ್ತಾ ಇರೋ ಇನ್ಸ್ಟಂಟೇನಿಯಸ್ EMFನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ ಅವರು. ಓಕೆ, ಸೊ ಹಿಯರ್ ಲೆಟ್ A be the area of the coil. Let A be the area of the coil and magnetic field B. So magnetic field na B anta ತಗೊಂಡಿದ್ದೀವಿ. Let n be the number of turns. Let n be the number of turns of the coil. Number of turns of the coil. Let theta be the angle between. Let theta be the angle between the area. Between the area and the magnetic field. Okay. So ee theta enide, it's the angle between the area and the magnetic field. If omega is the angular velocity, if omega is the angular velocity of the rotation of the coil, then e theta is equal to omega t. So here the theta value is equal to omega t. The magnetic flux linked with the coil is, the magnetic flux linked with the coil is pi b is equal to nba cos theta. So nba cos, in place of theta I can write omega t. So first we have to write the expression for magnetic flux. First ಏನು ಮಾಡಿದೀವಿ ನಾವು, expression for magnetic flux ನ ಬರ್ಕೊಂಡಿದೀವಿ. Next, from Faraday's laws, okay, what we can write, induce ಆಗ್ತಾ ಇರೋ EMF is minus d pi b by dt ಗೆ equal ಆಗಿರುತ್ತೆ. That is the statement of Faraday's law. So from Faraday's law we are writing induced EMF is equal to minus d pi b by dt. Now next steps are very simple. You have to substitute the value of pi b here and differentiate it. Minus d by dt of nba cos omega t. So here b, nba are constants. I will take out of the differentiation. Nba d by dt of cos omega t. D by dt of cos omega t. So if I differentiate this, I will get minus nba cos omega t differentiation is minus sin omega t into omega, which is a constant. So minus into minus plus ಆಗುತ್ತೆ. Induced EMF is nba omega sin omega t. So this omega t value can vary from minus 1 to 1. So E naught place ಅಲ್ಲಿ nba omega ಅಂತ ಬರೀತೀವಿ, or nba omega place ಅಲ್ಲಿ E naught. So this E naught is the peak value of EMF. Now I will substitute this here. E is equal to E naught sin omega t. So the value of E ranges from minus E naught to plus E naught. It's so simple, isn't it? So first we have to write consideration, draw the figure, and pi b definition in the nba cos theta. In place of theta we have to substitute omega t. Next, using Faraday's law, E is equal to minus d by dt of pi b. So substitute the value of pi b here and differentiate it. You will reach here. Next, in place of nba omega, you can put E naught, which is nothing but peak value of induced EMF, instantaneous EMF. So E becomes equal to E naught sin omega t. Let's move on to the fifth main. So here you have to again answer any 2 out of 3 questions. Each question carry 5 marks. The 30th question is, obtain the expression for fringe width of interference fringes in Young's double slit experiment. So fringe width expression na find out ಮಾಡಬೇಕು using Young's double slit experiment. So here is the source. 2 slits are placed, S1 and S2. The distance between them is D. Distance of the screen, on screen place ಮಾಡಿದೀವಿ here. So the distance of the screen from the slits is capital D. Now let's consider a point P where the nth bright or dark fringe, ಯಾವುದಾದ್ರೂ fringe form ಆಗಿದೆ ಇಲ್ಲಿ. So the distance of this nth fringe from the center O of the screen is x. So all which I just said you have to write under consideration. Consider a source S emitting some light of wavelength S1 and S2 are the two slits separated by a distance d. Light emitted from the source S is passing through the slits S1 and S2. A screen at a distance of d from the double slits is placed. Let waves emitting from S1 and S2 superimpose with each other and at a point P. The point P is at a distance of x from the center. Alright, so ishtu neevu considerations alli you need to write. Next, the first thing which you see here is two right angle triangles. S1PA, another one is S2PB. So from triangles S1PA and S2PB, I can write Pythagoras theorem baritini. S1P square is equal to S1A square plus PA square. Okay, so I'll write S1P square is equal to S1A square plus PA square. In place of S1A square, illinda illigiro distance d square plus, okay, so from here to here it is x, okay, idishtu d by 2 ide, this is d by 2 and this one is also d by 2. So x minus d by 2, x minus d by 2 whole square. Similarly, S2P square is equal to S2B square plus PB square. So S2B is again d plus PB square is x plus x whole square, x plus d by 2 whole square. Alright, x jote plus d by 2 ide. So this is equation 1 and this one is equation 2. So I'll write 2 minus 1. Subtraction ಮಾಡ್ತಾ ಇದ್ದೀನಿ. S2P square minus S1P square is equal to d square plus x minus d by 2 whole square minus S1P is, sorry, plus d by 2 minus S1P is this one, d square plus x minus d by 2 whole square. Alright, now simplify it. D square plus expand it, x square plus 2x d by 2 plus d square by 4. Idanna using a plus b whole square formula ತಗೊಂಡು expand ಮಾಡಿದ್ರೆ ಇಷ್ಟಾಗುತ್ತೆ. Next, ಇದನ್ನ ಮಾಡಿದೆ minus into plus d square minus d square minus x square minus d square by 4 minus into minus minus 2x d by 2 ಬರುತ್ತಲ್ಲ, ಸೊ ಆ ಮೈನಸ್ ಈ ಮೈನಸ್ ಜೊತೆ ಮಲ್ಟಿಪ್ಲೈ ಆಗಿ 2x d by 2 ಬರುತ್ತೆ. 2 2 and 2 2 ಇಲ್ಲೂ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಪ್ಲಸ್ d square minus d square plus x square minus x square. So you'll have S2P square minus S1P square is equal to, here is there is one xd, here also there is one xd. This will also get cancelled. 2xd you will have. This S2P square minus S1P square is in the form a square minus b square. If you expand, you will have S2P minus S1P into S2P plus S1P, that is equal to 2xd. Now I need only S2P minus S1P. So S2P minus S1P is equal to 2xd divided by S2P plus S1P ಆಗುತ್ತೆ. Okay, here from if the two slits are kept very close to each other, S2p plus S1p ವ್ಯಾಲ್ಯೂ 2D ಆಗುತ್ತೆ. ಇದನ್ನ ಡೈರೆಕ್ಟ್ಲಿ ತಗೋತಾ ಇದೀವಿ ನಾವು. ದಿಸ್ ಇಸ್ ಆಕ್ಚುಲಿ ಬೈ experiment. Alright, what Young found was S2p plus S1p is equal to 2D. Let's substitute this here in equation number 3. So you will have S2p minus S1p is equal to 2xd divided by capital 2D. 2 cancel ಆಗುತ್ತೆ and you will have S2p minus S1p is equal to xd divided by d. Further, now this is equation 4, which is an expression for actually the path difference. S2p minus S1p is path difference. Now here let S2p minus S1p is equal to n lambda. Alright, assuming that the fringe which has formed at a distance of p is a bright fringe, path difference for a bright fringe is n lambda. So substitute it here. N lambda is equal to xd divided by d, and from this x is equal to n lambda d by d. Okay, this is equation 5. Now suppose this is the nth fringe. ಇಲ್ಲಿ ಬಂದಿರೋದು nth fringe ಅಂತ ಅಂದ್ರೆ ಇದನ್ನ xn ಅಂತ ಹೇಳ್ತೀನಿ. ಅಂದ್ರೆ distance of the nth fringe from the center equation is n lambda d by d. Next ಇದಾದ್ಮೇಲೆ nth fringe ಆದ್ಮೇಲೆ n plus 1th fringe ಇರುತ್ತೆ. ಸೊ x n plus 1 ನ n place ಅಲ್ಲಿ n plus 1 ಹಾಕ್ಬೇಕಷ್ಟೇ into lambda d divided by d. So this is equation 6. ಫ್ರಿಂಜ್ ವಿಡ್ತ್ ಬೇಕು ಅಂದರೆ nth ಫ್ರಿಂಜ್ ಮತ್ತು n plus 1th ಫ್ರಿಂಜ್ ಡಿಸ್ಟೆನ್ಸ್ನ ಮೈನಸ್ ಮಾಡಿದಾಗ ವಿ ವಿಲ್ ಗೆಟ್ ಫ್ರಿಂಜ್ ವಿಡ್ತ್. ಸೊ ಫ್ರಿಂಜ್ ವಿಡ್ತ್ ಇಸ್ xn plus 1 minus xn. xn plus 1 is here n plus 1 into lambda d by d minus xn is n lambda d by d. Now let's multiply this with the bracketed terms is equal to n lambda d by d. Lambda d by d na n inda multiply ಮಾಡಿದ್ರೆ next multiply it further, lambda d by d minus n lambda d by d. So this and this will get cancelled and you will have beta value as lambda d by d. So this is the final expression for fringe width using Young's double slit experiment. It's very easy derivation. First you can see two triangles are there. Using Pythagoras theorem, find out what is S1p and what is S2p, then subtract these two values, S2p square minus S1p square. So you'll be left with 2xd. Next on the left hand side it is a square minus b square form alli ಇದೆ. ಸೊ a plus b into a minus b ಫಾರ್ಮ್ಯಾಟ್ ಅಲ್ಲಿ ಸ್ಪ್ಲಿಟ್ ಮಾಡಿ ಬರೆದ್ರೆ ಎಕ್ಸ್ಪ್ಯಾಂಡ್ ಮಾಡಿ ಬರೆದ್ರೆ S2p minus S1p into S2p plus S1p ಬರುತ್ತೆ. ಸೊ ಇದನ್ನ ಡಿನಾಮಿನೇಟರಿಗೆ ತಗೊಳ್ಳಿ. S2p plus S1p from the experiment is 2D, substituted, cancel ಆಗುತ್ತೆ. So this S2p minus S1p is actually path difference. So we have two conditions for path difference. Path difference in case of bright fringe, in case of dark fringe. In case of bright fringe I have taken it is n lambda. Even if you use dark fringe case, then also bright fringe width is lambda d by d ne barutte. But for easy calculation we have taken bright fringe. So S2p minus S1p is n lambda. Again this n lambda ಇಲ್ಲಿ ಈ ಪ್ಲೇಸ್ ಅಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ you will have n lambda is equal to xd divided by d. From this x is equal to, if you rearrange, n lambda d by d ಆಗುತ್ತೆ. If this is the nth fringe distance, x n subscript you have to put is equal to n lambda d by d. Next this is the distance of nth fringe. Next is n plus 1th fringe. The distance of n plus 1th fringe is x n plus 1 is equal to, in place of n, place n plus 1 into lambda d by d. Next subtract these two values. So xn plus 1 minus xn, solve it, and you will have beta is equal to lambda d by d. So the next question is, using Bohr's postulate, derive the expression for radius of the nth stationary orbit of electron in hydrogen atom. Hence write the expression for Bohr's radius. Okay. So it's a very simple derivation from the chapter atoms. Here you have to find out the radius of nth stationary orbit using Bohr's second postulate actually. So consider an atom of mass number, atomic number Z. Okay, let Z is the atomic number, and charge on the nucleus is plus Ze. So what is this Ze? Charge on the nucleus. Let an electron is having the mass m and charge e. M is the mass and e is the charge, minus e is the charge on the electron which is revolving around the nucleus. Let v be its velocity. Using Coulomb's law, the force acting between the nucleus and the electron, electrostatic force Fe, is given by 1 divided by 4 pi epsilon naught Ze square divided by Rn square. Rn andre radius of the nth orbit. So this is equation 1. Next, this electrostatic force provides necessary centripetal force. So general formula for centripetal force is mv square by r, but ಇಲ್ಲಿ subscripts vn and rn ಅಂತ add ಮಾಡಬೇಕು because it is in the nth stationary orbit. This is equation 2. So electron revolve ಆಗಕ್ಕೆ ಬೇಕಾಗಿರೋ centripetal force electrostatic force apply ಮಾಡ್ತಾ ಇದೆ. So we can equate these two. mvn square divided by rn is equal to 1 by 4 pi epsilon naught Ze square divided by Rn square. So 1 Rn will get cancelled and you will have mvn square Rn is equal to 1 divided by 4 pi epsilon naught Ze square. Ishtu ಉಳಿದಿದೆ. This is the value of mvn square Rn. Now from Bohr's postulate we know, from Bohr's second postulate actually, from Bohr's second postulate, we can write Ln, angular momentum, is the integral multiple of mvn Rn, angular momentum ige formula. So from Bohr's postulate it is nh divided by 2 pi. So mvn Rn value nh divided by 2 pi. This is equation number 4. Now I will divide equation 3 by 4. So before dividing it, I will also square it. Okay, mvn Rn whole square is equal to nh divided by 2 pi, which means I am squaring on both the sides. Alright. Now I will divide this equation 5 by equation 3. So if I divide, I can write mvn Rn square 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 because it is whole square. It is equal to n square h square divided by 2 pi, 2 square pi square divided by this one. Alright, whole divided by mvn square Rn. Here we have 1 divided by 4 pi epsilon naught Ze square. So 1m goes, vn square goes, 1 Rn goes. So here mRn is equal to n square h square divided by 4 pi square into reciprocal ಮಾಡೋಣ 4 pi epsilon naught divided by Ze square. So 4 and 4 and single pi goes. You will have mRn is equal to n square h square epsilon naught divided by pi z e square. ಇಷ್ಟು ಇದೆ. ನಮಗೆ ಬೇಕಿರೋದು ಓನ್ಲಿ ಆರ್ ಎನ್. ಸೊ ಆರ್ ಎನ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎನ್ ಸ್ಕ್ವೇರ್ h square epsilon naught divided by this m comes here to the denominator, m pi z e square. So for hydrogen like atoms, for hydrogen this z is actually equal to 1. So Rn is equal to n square h square epsilon naught divided by m pi e square, m pi e square. Now for the Bohr's radius and also find the expression for Bohr's radius anta ಹೇಳ್ತಾ ಇದ್ದಾರೆ ಅವರು. So for Bohr's radius here n is equal to 1 ಇರುತ್ತೆ. So if I substitute n is equal to 1 here, a naught is equal to h square epsilon naught divided by pi m e square ಆಗುತ್ತೆ. ಎಕ್ಸ್ಪ್ರೆಷನ್ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. ಸೊ ಎಕ್ಸ್ಪ್ರೆಷನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿದ್ದೀವಿ. ಆ್ಯಕ್ಚುಲಿ ಇಫ್ ದೇ ಆಸ್ಕ್ ಯು ದ ವ್ಯಾಲ್ಯೂ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು ಬೈ ಸಬ್ಸ್ಟಿಟ್ಯೂಟಿಂಗ್ ದ ವ್ಯಾಲ್ಯೂಸ್ ಆಫ್ ಹೆಚ್ ಎಪ್ಸಿಲಾನ್ ನಾಟ್ ಇ ಎಮ್ ಪೈ ಎಕ್ಸೆಟ್ರಾ, ಬಿಕಾಸ್ ಆಲ್ ದೀಸ್ ಥಿಂಗ್ಸ್ ಆರ್ ಕಾನ್ಸ್ಟೆಂಟ್. But since they have asked only to find out expression, we have find out the expression. So centripetal force, electrostatic force expression na equate ಮಾಡಬಾರ್ದು. mvn square rn is equal to ಒಂದು expression ಬರುತ್ತೆ. Next using second postulate, mvn rn is equal to nh by 2 pi ಬರುತ್ತೆ. ಇದನ್ನ squaring on both sides ಮಾಡಿ ಈ equation fifth ನ equation 3 ಇಂದ division ಮಾಡಬೇಕು. ಆಮೇಲೆ ಉಳಿದದೆಲ್ಲ ಮ್ಯಾಥಮೆಟಿಕಲ್ ಸಾಲ್ವಿಂಗ್, ಆರ್ ಎನ್ ಬರೋವರೆಗೂ ಅದನ್ನ ರೀಅರೇಂಜ್ ಮಾಡಬೇಕು. ದೆನ್ ಫಾರ್ ಹೈಡ್ರೋಜನ್ z is equal to 1, ಫಾರ್ ಬೋರ್ಸ್ ರೇಡಿಯಸ್ n is equal to 1. ಸೊ ಬೋರ್ಸ್ ರೇಡಿಯಸ್ ನ ಆರ್ ಎನ್ ಪ್ಲೇಸ್ ಅಲ್ಲಿ a ನಾಟ್ ಅಂತ ಬರೀತಾರೆ, h ಸ್ಕ್ವೇರ್ ಎಪ್ಸಿಲಾನ್ ನಾಟ್ ಡಿವೈಡೆಡ್ ಬೈ ಪೈ m e ಸ್ಕ್ವೇರ್. ನೆಕ್ಸ್ಟ್ ದ ಲಾಸ್ಟ್ ಕ್ವೆಶ್ಚನ್ ಇನ್ 5 marks explanatory questions. What is rectification? Explain working of a PN junction diode as a half wave rectifier and draw the input and output wave forms. So here first rectification na define ಮಾಡಿ ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. So this rectification is a process of conversion of AC to DC. Next I'll write the half wave rectifier definition. So this half wave rectifier is a device which converts only half cycle of AC to DC. So a rectifier consists of all these things. You have to also write input and output waveforms. This is the input waveform, this is the output waveform. So there is a source of AC connected to the primary of the transformer use ಮಾಡಿದ್ದಾರೆ. Secondary across ಅಲ್ಲಿ ಒಂದು diode is used and across the diode final load resistance RL is connected. You have to write down this figure and also these waveforms also. Here when due to mutual inductance the primary in the across secondary EMF induce ಆಗುತ್ತೆ. Okay, and this cycle will be across this A. So during the positive half cycle the diode is said to be forward bias. Positive to idu triangle side ideyalla, that is P side. So forward bias. At this moment you will get output. See here we have got a curve. Next, when the next half cycle enters this point A, this diode is said to be reverse bias, which means no output. See, there is no output here. So this process continues here. So only positive half cycles are getting converted into DC. Negative half cycles iddaga output 0 bandirutte. So how we have to write this? The circuit connections are made as shown in the figure. A source of AC is connected across primary of the transformer. The diode is connected to the secondary of the transformer. Output is obtained across a load resistance RL. So this paragraph is saying about the setup of this rectifier. The secondary of the transformer supplies the desired AC voltage across terminal A and B. During the positive half cycle of input AC, the point A is positive with respect to point B. Then the diode is forward bias, hence the current flows through the load resistance. Next, cycle reverse adaga enagutte. During the negative half cycle of input AC, the point A is negative with respect to the point B, hence diode is reverse biased. Hence output during this negative half cycle is 0. The diode gives output only for the positive half cycle, hence it is called as half wave rectifier. Next, ಇನ್ನೊಂದು ಲೈನ್ ನೀವು ಬರಿಬಹುದು, this cycle continues. Whenever this point A is positive, the diode gives output. Whenever the point A is negative, the diode does not give any output. So this is about the question, what is the rectification? Explain working of a PN junction diode as a half wave rectifier. Draw the input and output waveform. So idukku marks irutte, input and output waveforms ige important, idu ನೀವು ಬರೀಲೇಬೇಕು. So last in the question paper which we have discussed, model question paper discuss ಮಾಡಿದ್ವಲ್ಲ, ಅದರಲ್ಲಿ full wave rectifier ಕೇಳಿದ್ರು. So March 2020 question paper alli they have asked half wave rectifier, which means this concept is very important. So this is all for today's video. In this video we have solved 5 marks explanatory questions of the question paper March 2020. If you want to download the detailed solution of this question paper, you can download it from the description box. So in the next video we will be solving 5 marks numericals of the same question paper. So thank you so much for watching, and share this video so others can also take advantage of this. Take care. Thank you so much for watching.